Can y'all hear me?
Hello, class. We're starting lesson 2 for the effects of alcohol. Our learning objectives is to write an equation of a line given a description of the relationship. Also, to write an equation of a line that models data from a table, and to write an equation of a line from a graph of the line, and graph a line by plotting points. As long as algebra is taught in school, there will be prayer in school. Cokie Roberts. It's no secret that alcohol consumption by college students is common and that overindulgence can have many negative effects in both the short and long term. And if anything, the problem is getting more serious. At my school alone, 21 students were hospitalized for alcohol poisoning during one recent weekend. When someone makes a choice to drink, they're affected as long as the alcohol remains in their bloodstream. There are many theories on how to hasten the sobering up process: black coffee, ice cold showers, greasy food, drinking lots of water. The truth is that none of these have any effect whatsoever on blood alcohol concentration. BAC. You can try every mythical treatment known to man, but at the end of the day, the only thing that will bring down BAC is time. So far, we've studied a wide variety of quantities that can be modeled using linear equations. In this lesson, we'll use the time required to sober up and other quantities to study writing linear equations that model situations in greater depth. But first, let's talk about something much more positive: pizza. The student organization you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked to deal with a local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food, and of course, you'd like to know how many pizzas you can get and stay under budget. We'll attack the problem in several different ways. Number one, it says use a numerical calculation, include all details, and don't forget to write the number of pizzas you can buy. Okay, so basically, we have a $175 budget, and the pizzas are $9 each. If we put this in our calculator, it will give us approximately 19.4 pizzas. But as you know, since we cannot buy zero point 0.4 of a pizza, that means that we can only afford 19 pizzas. Okay, number two, write an equation that represents the total cost C of ordering P pizzas. Remember, each pizza costs $9. So C is the total cost, and then $9 is the slope, and then P is the pizzas. So is the cost is $9 per pizza. Now, when you write this as your formula, you'll drop the dollar sign. So it just be C equals 9 times P, but it's assumed to be in dollars. Now, we move on to the next page. It says complete the table, then use it to estimate the number of pizzas you can buy. Okay, first of all, if you have 0 pizzas bought, the cost is $0. All of the rest of these pizzas we will multiply by 9. So it'd be 45, 90, 135, 180, 225, and $270. So again, we're using C equals 9 times P, and that's what gives us these values. Okay, so it says complete the table, then use it to estimate the number of pieces you buy. Now remember, we said we could get 19 pieces, so it'll be somewhere between 15 and 20. Now we come here to number 4. It says use the information from the table to draw a graph with the number of pizzas on horizontal axis and the total cost on the vertical axis. Make sure you label the scale on each axis. Use your graph to estimate the number of pieces that can be bought for $175. Try to ignore the answer you found in question one and use only the graph. Okay, so we have the number of pizzas and we have the cost. Now we want to label these values here. Now, if you notice, pizza, the most that pieces that we have is 30. Now, of course, this is going to be our zero on either side. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 10 tick marks here. So since we have what 30 pizzas bought here, we probably could do, let me see. Okay, it's 10. So if we did 3 each, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So that will cover all of them. Okay, next, down the side here, we go from 0 to 270. We count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 10. I would suggest that we go by 30 so we'll cover everything. So this would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. And we know that this is in dollars. Now we're going to graph these points. We have 0, 0. Then we have 5, 45. So 5 would be somewhere here. 45 would be almost here. Then we had 10, 90. So 10 will be about here. Then we'll go up here to 90. Then we have 15, 135. So let's see, 135 would be about here. Then we got 20. What's that? 20 and 180. So it's about here. 20, 180. Then we had 25, 225. Should be about here. And then finally, we will have 30, 270, which would be here. Now, if you notice here, we connect these points. Well, it gives us basically a straight line. And remember, we need to use our arrowhead to make sure that that lets it be known that it goes on forever. Now, it says use your graph to estimate the number of pieces that can be bought for $175. So what we would do here, 175 is about here, and we would go about here. So if you notice here, this is a little bit above, a little bit past 18, so it is 19. Now we could draw a little dotted line here to let us know that this is what we drew it from. So our answer, it looks like 19 pizzas can be bought. Okay, number 5. Since we want to spend at most $175, this is a good place to use an inequality. Write an inequality that can be used to find the number of pieces you could buy for at most $175. Then solve the inequality and use the result to decide on the number of pizzas you can buy. So we know 9 times how many pizzas we have must be less than or equal to 175. because this is signifying at most. So at most would be basically the equivalent of 175, and then everything below it would be the less than. Now we will go through and solve this. Divide each side by 9. P would be less than or equal to 19.4. And we know that's an approximation. Yeah, so it's basically what we've been solving earlier. You can buy at most 19 pizzas. That's the most amount of pizzas you could buy is 19. All right, now we move on. Okay, number 6. It says, what's the slope of the line you drew in question 4? What does it represent? So we know the slope is 9. And it represents the price per pizza. Okay, what's the y-intercept of the line? What does it represent? The y-intercept, you bought no pizzas, you will end up with no cost. No pizzas will cost you nothing. Nice job so far, but did we forget to mention the $10 delivery charge? Sorry, you'll have to rework the problem. Keeping in mind that we want to know how many pizzas we can get for at most $175 at $9 each, plus a flat fee of $10 for delivery. All right. So our equation would be C equals 9P plus 10. Because now we have a y-intercept. So at 0, it'll be $10. So basically, we'll still multiply all these by 9, but then we have to add 10 to it. So it'll be 55. Or you could go back to the old table and then just basically add 10 to the values that you have for each one of these. So it'll be still somewhere between 15 and 20. This 175 still falls in between 15 and 20. Now number 10 says use the information from the table to draw a graph with the number of pizzas on the x-axis and the total cost of the y-axis. Don't forget to label a scale on each axis. Use your graph to estimate the solution to the problem. All right. So what we would do here, again, I think we had 10 lines, but we still just go to 30. So it'd be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. But now we still will go up to 280. So down the side here, we went by 30s. All right. We still was able to encompass everything. Now we're going to graph. You know, 0, 10 would be about here. And then we have 5, 555 should be about here. Then we have 10, 100. It's about here. And we have 15, 145. Then we had 20, 190. Then we had 25, 235. Then we had 30, 280. Okay, and it still form about a straight line. Now, if we look here, we have 175 that we need to get, which is about here. I'll just draw a line here, and I have it broken up by erasing a little bit, just to let you know that this is here. So when we look here, it looks about to be like 18 pizzas. So the height is 175, and it looks like 18 pizzas. All right, move on to the next page. Write and solve an inequality that can be used to find the number of pieces you could buy with the delivery charge added. Write the solution to the problem in a full sentence. Okay, so first we will add 9p plus 10 is less than or equal to 175. So we subtract 10 on both sides. 9p is less than or equal to 165. Divide each side by 9. And p is less than or equal to 18.3. And we could say you can buy 18 pizzas without spending $175. I should say over $175. Okay, number 12. What is the slope of the line you drew? What does it represent? The slope is 9. And it represents the cost of each pizza. Okay, number 13. What is the y-intercept of the line you drew? What does it represent? The y-intercept is the delivery cost. And it's represented by 0.10. So you pay $10 for the delivery before you pay for the actual pizza. Number 14. Now here's the key idea. Look back at your answers to question 8, 12, and 13. The slope was 9. The y-intercept, we had 0, 10. And the equation is C equals 9p plus 10. That's basically what we get from this. All right, now, move on. It says there's a very useful lesson to be learned from questions 12 through 14. The $9 that it costs for each piece is the rate of change of your cost as the number of pieces increases. And we know that a constant rate of change for some quantity represents the slope of a line when you graph the quantity. The $10 is the amount you would pay just for delivery. So 0 pieces correspond to $10, and the point 010 would be on the graph describing total cost. In fact, it would be the y-intercept. The equation describing the cost can be written as y equals 9x plus 10, where x is the number of pizzas. Hopefully you're okay with using x and y rather than CMP like we've been doing. Remember, the actual symbol you use for a variable quantity doesn't matter. Notice that the coefficient of x, which is the number x, is multiplied by is the slope of the line. Also, the constant term, which is a term without a variable, is the second coordinate of the y-intercept. In algebra, we call an equation of this form the slope-intercept form of a line, because the two constants in the equation are the slope, the rate of change, and the y-intercept, the starting value. The slope-intercept form is usually written as y equals mx plus b, but can also be written as y equals b plus mx to match the order of your answer to question 14. Write an equation of a line. When a line has a slope m and the second coordinate of its y-intercept is the number b, then the equation of that line is y equals mx plus b, which we've been using. So for 15, it says a small business had just 12 employees when they opened their doors, but they have been adding employees at the rate of 4 per month since then. Write a linear equation that describes the number of employees in terms of the number of months after the company was founded. So we could use E for employees is equal to, they said we're adding employees at the rate of 4 per month. So we could make it E equals 4 times months. But then remember, we started with 12 employees. All right, 16. What are the slope and y-intercept of this line? The slope is 4, and the y-intercept is 0, 12. What do they tell us about the company? Okay, the slope tells us how many people are added every month. The y-intercept tells us that the company started with 12 employees. Now it says use this information to draw a graph of your equation. Be sure to label a scale and the axis. Okay, so first of all, we know it's 12 months in a year. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We only have 10 values here. So we could, I mean, technically this would be months. And then we could put number of employees. All right. And remember, employees increase like 4 per month. So this is a general sketch here. So I mean, we could go by twos here, even though that'll be take us to 24 months. So we might should go just by ones, even though we'll be 2 months off. Okay, next we have the number of employees. Now we start with 12 and we go up 4 per month. Now, if you think about it, since 4 goes evenly into 12, let's just go by fours. 4, 8, 12, 16, 20, 24, 28, 32, 36, and then 40 at the top. Okay, now go here to the next page. It says graph an equation in slope-intercept form. It says plot the y-intercept. Well, you know what? We're going to actually go through this process. So you can read 176 at your leisure. And the top of 177, we're going to go ahead to the top of page 178. It says, after being arrested for driving under the influence, a well-known starlet was found to have 3.5 times the legal limit of alcohol in her blood. What was her blood alcohol concentration? So we know this person had 3.5 times the legal amount. Now on the back here, it tells us here that the legal amount for most states is 0.08, which is 0.08% of the person's blood. So we'll put 0.08%. And if you multiply that, that would give us 0.28%. Now, explain exactly what your answer to question 1 means. It means that 0.28% of her blood is alcohol. Number 3, describe some of the effects the arresting officers may have been able to observe at the time of the arrest. Slurred speech, now I went up a little too high with the blood alcohol, so it's not slurred speech. Actually, if we go back here to the previous page, it tells you here, we have the observations: relaxation, slight body warmth, sedation, slow reaction time. Those are a few that we could list here. So we could say trouble walking, because if you have double vision, you're going to have trouble walking. Double vision, nausea, and vomiting. John Q. Bonehead decides it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens, and a BAC test finds a level of 0.16 at 2 a.m. Unlike most other drugs, studies have shown that alcohol leaves the bloodstream at a constant rate. The table shows his BAC every hour after the arrest. Okay. What is the slope of the line describing? What is the slope of the line describing John's BAC? What does it tell us? Okay, well, if you notice this first, this is going down. You notice this is going down to 0.015. And then it's the same thing, 0.015, 0.015, and then 0.015. So it's consistently going down each hour, a negative 0.015. That is our slope. it tells us John's BAC is decreasing 0.015 per hour. Now, number 5, what is the y-intercept of the line describing John's BAC? What does it tell us? Okay, so it'll be 0, 0.16. That'll be the y-intercept. And what it's telling us is BAC at 2 a.m. was 0.16. All right, now we move on to the next page. It says, write the equation describing John's BAC with X representing hours after 2 a.m. and Y represent BAC. So yeah, Y equals 0.16 minus 0.015X, which we pulled here. Now, if you notice here, we wrote the y-intercept first and the slope. Now, if you want to write it the traditional way, you can write it like this here. The traditional y equals mx plus b. Now, when using an equation to model a situation, it's important to recall what specific information the equation provides. Restate your answer to question 6 in the form of a statement like this. If x represents blank, then y is equal to blank, which represents blank. Okay, so if x represents hours after 2 a.m., then y is equal to, we would ask this in class, but y is equal to a negative 0.015 plus 0.16. I'll write it here. All right. Now, then also it says represents. And what you will have to put here, because this is going to be longer than this box, this person's blood alcohol after 2 a.m. Number 8, we've learned about several features of graphing calculators that allow us to study the information provided by an equation. Substituting in values for variables, making a table, and making a graph come to mind. Unlike these features, discuss whether or not the equation you wrote tells the story that it's supposed to. More detail is always better. The equation shows a BAC of 0.16 at 2 a.m., decreasing in the slow, steady rate after that time. Number 9, what would Mr. Bonehead's blood alcohol concentration be at 3:30 a.m.? Remember, eating greasy food won't change it. So if we're looking here at 3:30 a.m., we know that's an hour and a half past the 2 a.m. So we would have x is equal to 1.5 because x is in hours. So we would do some substitution. It'd be y is equal to a negative 0.015 times 1.5 plus 0.16. Now when you put this all in your calculator, it'd be 0.1375. Now number 10, it says how many hours would it take for his BAC to drop below the legal driving limit of 0.08? He can take a cold shower if he likes, but it won't help. Set up and solve an inequality to answer this question, please. So you have negative 0.015x plus 0.16 is less than 0.08. So we subtract 0.16 on both sides. So negative 0.015x less than or equal to negative 0.08. Now we divide each side by negative 0.015. We will have x. And then because we divided by a negative, it will change the direction of the inequality. So it'll be x is greater than negative divided by a negative is a positive. And then you have here, which when we simplify, it will give us 5 1/3. So it'll be greater than like about 5.3 repeating. Or you could have put x is greater than, let's see, 16 over 3, where x is greater than 5 1/3. Now we come here to problem number 11. It says, what information would you need in order to draw the graph of your equation? We need at least 2 points on the line. We need the slope and y-intercept. Again, we need at least 2 points on the line. We need the slope and y-intercept to draw the graph. All right, number 12. It says graph the line on a coordinate system provided. Make sure that you choose and label an appropriate scale on each axis. Now, look here at the blood alcohol. Gotta go back to page 177. Now we see those values here. So we know this would be our x value. No, I'm sorry, this would be our y value, the BAC. And this would be our x value, so the observable effects. Now, with the observable effects, you notice here that, well, I'm sorry, it's supposed to be the hours after 2 a.m. The hours after 2 a.m., the hours after 2 a.m., not many of those hours, but we're going to go by twos. So it'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. In our BAC, our lowest BAC is 0.02, but we know we can make a zero slot here, and all of these can go up by 0.2. All the way up to 0.20. Okay, so now we draw a graph. Everything is labeled. Now 13, it says, what is the x-intercept? Oh, we need to graph this. So we can grab a couple points here. So we have 0 and 0.16. Which is here. 0 and 0.16. Then we just need to grab up one more value. We can go 2 and I think we did. Yeah, we substitute in 2. Let me put the equation here. So y is equal to a negative 0.015x plus 0.16. All right. Now, if we go to 2, we put in 2 here. This will be a negative 0.03 plus 0.16. This is 0.13. So we'll make x2 and y will be 0.13. Two. Okay. Let's take a look here. Hey class, I realized I just made an arrow down the side here up until we got to 8. It was supposed to be 0.02, 0.04, 0.06, and 0.08. And now that we have that, we have 0.13, which would be about here. I'm sorry, that was 2 and 0.13, which would be about here. So we only really needed 2 points. And then we could go ahead and go on down. I'm not saying this is accurate, but it'll be very close. It says, what is the x-intercept? It's a little bit past 10. So I would say the x-intercept. But before we do that, let's take a look. Let's use this formula here. So we have the x-intercept is when y is 0. So y will be 0 is equal to a negative 0.015x plus 0.16. We'll subtract 0.16. So negative 0.16 is a negative 0.015x. Divide each side. And this will give us, it'll be approximately 10.67. So our x-intercept will be 10.67, comma 0. So this is saying it will take 10.67 hours for the BAC to return to 0. It says sketch an example of a line with a positive slope. Label this line on the graph below. So positive slope, just basically showing a rise. So positive slope. Now remember, it's a rise from going from left to right. So now it says sketch an example of a line with negative slope. So we could say this is negative slope. All right. And remember, it's from left to right. If you notice from left to right, this line is falling. Okay, last but not least, can you describe what a line with a slope of 0 would look like? Sketch an example and label the line on the graph below. All right. Say a 0 slope is just basically a horizontal line. Doesn't matter where you draw it at. It's still going to be 0, whether it's at the top or the bottom. Okay, now that is basically it from section 2.4. If you have any questions, please contact me. Have a wonderful day.